So hey everybody, today's topic is ground circuits on our engines. This one, oftentimes I get something on the channel that springs me to want to delve into a topic a little deeper. And currently I've been going back and forth for a few weeks with somebody who's trying to diagnose actually an oxygen sensor circuit. One of the things he found in working on it, one of the messages I got back, was that he had a voltage on the ground side of his oxygen sensor circuit from the ECM back to ground, which seems to be a really odd thing to happen. And so we've been working a little bit about how do you troubleshoot the ground side. So I thought, the ground, electrical grounds on the engine and on the car is really kind of an afterthought, right? Everybody comes in and picks up their meter and heads for diagnosing the power supply to something, and we really often don't look at what the ground systems look like. So I'm going to deal with grounds in general. Specifically, they're slanted toward General Motors products, but what do you need to think about when you're looking at the grounds, and what do you do to diagnose them? If you go into a GM service manual, at least from the mid-80s on, this is the type of a display that you'll get, the type of a wiring diagram that you'll get, which is the basic layout for the ground distributions. And in this particular case, this one, it says ground G112, which is this little dot down here at the bottom where it says ground. That's G112. That's actually the grounding point. And in this case, see, there's an ECM ground, and it comes off pin D6 off connector C2, tan wire, and I believe that is the oxygen sensor ground, that comes back and grounds to this point. Along with the spark control module, along with, in this car, airbag module. And those things come down. And there are several things of note when you get into dealing with ground circuits. First off is the G means ground, and G112 in this case is the location of the ground. The S's are splices. So inside the wiring harness, you'll have several different wires come together, and the harness is built with a splice in it to put them together and send them downstream. And then here you'll see there's a C number, and the C is the connector. So there's a connector between the splice and the ground where harnesses connect together. Here's the G118 is another ground point. And this one's complex enough that it goes on to 2 pages. This one picks up air conditioning, cooling fans, blowers, some things actually from the instrument cluster, printed circuit, vehicle speed sensors that splice together and come down. And if I go to the next page, each one of these connects together. There's another one from the ECM, and these go down to a G118. And then there's a thing called a braided ground strap that goes to the body and or chassis. On a unit body car, they're usually synonymous. So this is what that circuit looks like if you put the 2 pieces together, which is 2 pages in the service manual. Now, typically these are powertrain related, and these are actually located on the engine. And if you go through, this particular one is this is a power distribution page. But if you go down the list on the power distribution, see, you'll hear G100, you'll see G101 based on the engine VIN codes, and they'll tell you where those are. So this one says G100 is on the lower right hand front of the engine. This one's on the left hand inner fender panel near the battery. So you can go through the lists and you can find where these points are supposed to be for when you're doing diagnostic. Now, in this particular case, we're working on a V8, and GM at least, and maybe other companies too, GM and Chevy in particular really likes using the back sides of the cylinder heads on their V engines. So when you get into a V8, you end up with these points at the back side of the engine. They're sometimes kind of hard to reach because they are on the back of the engine. And they'll use those for V6s as well. And I know on newer ones, I've seen them on the back of LS engines and pickup trucks. It's a very common location because if you think about it, right, you don't want any more wire than you need to have, for one. For two, many cases the ECM is trying to get ground returns for signals it sends out to a sensor, and the sensor is screwed into the engine block. So you want an engine path back to the ECM to make that ground return. And so, what's the shortest distance between the interior of the car and the engine? It's the back of the cylinder heads. It's a nice place. They dress it, they tighten those down, and you're in good shape. On the V8s that I've worked on, it's a stud. So you thread a stud into the back of the cylinder head and tighten that down, and then you have a nut on top of that and a couple of ring terminals that you then clamp down with that nut. So now if you want to test those circuits, what do you need to do? Well, I'm going to give you some kind of cartoons here rather than trying to do this under hood. But if you have an ECM PCM, and many times it has multiple circuits that it has multiple grounds. So like an oxygen sensor is a very sensitive circuit. It has its own ground wire by itself. And so, you may have 1, 2, or 3 that come to a stud on the back of the engine. The engine has to get grounded back to the chassis or to the body or to the dash structure on the below the windshield. And oftentimes they'll use just a braided copper strap that's bolted to the engine on one side and then bolted to the sheet metal on the other side, because you want a good ground return there. The battery goes to chassis or body ground. Again, if you had a pickup truck with a separate frame, you have to watch where those ground straps go, because then you'll have a ground strap perhaps between the body and the chassis, as well as one that goes to the engine, as well as to the battery itself. And then I'll throw in a little cartoon here for lights. You've got tail lights in the back of the car. They'll ground to the body somewhere in the back so that you get a ground return all the way up. And we'll talk about those a little later because they're even different than dealing with engines. And then up here you have dash components, which is you probably you have maybe your radio or even the heater blower system inside, and they'll come to a ground strap that may go to some place like the steering column, somewhere in I'll call it the cross car brace that holds up the instrument panel, and they'll ground to that because it's normally grounded well into the body structure. So I kind of like to think about this as a linear model, right? You've got all these different pieces, but how do you go test it, right? So if you figure that you've got a power feed from the battery into the ECM, and remember, if you're working with ECM circuits, oftentimes there are multiple feeds there as well. You'll have power feed to the ECM that's constant. You'll have another power feed that goes through the ignition switch, and sometimes multiple that go through the ignition switch, so that they have redundant paths. And you just need to be prepared for that. So if you have an ECM ground, you've got to, you get out your meter and test from, put a probe on, right? A probe at the pin on the ECM, and then sometimes you'll need an extension lead, but the first level would be to go from the ECM to the crosscar brace to the body structure to a known good ground, and see if you get a good ground, right? You can put it on resistance and let it auto range. Let me take a step back for a second. Even on my little chart here, I've kind of got it backwards, but start with DC voltage. And again, it could auto range, but I would normally put it in a voltage range where I get maybe full full screen, a tenth of a volt is as far as I would go down. See if you have, sometimes when you're dealing with millivolts, you get stray signals, and sometimes it's hard to get a 0 millivolt. But you could go to tenths or hundredths of a volt, and that would probably be enough. But before you put your ohm meter on a circuit, make sure you're powered off. Make sure you don't have voltage on it, because if you have significant voltage, more than millivolts, you're liable to damage your ohm meter. So first level is make sure you don't have any power on the circuit. I mean, it's even better if you pull the battery, but I know a lot of times, pulling the battery has other implications, because you're going to clear memory locations and things, and just be careful that when you put your ohm meter on something that you're not putting it on power. Assuming you have no voltage on here to begin with, and you put your ohm meter on the ECM terminal, then go all the way to chassis. You can do that inside the car. What kind of a resistance reading do you get? I mean, and it ought to be 0, and I'll say 0, maybe 1 ohm, maybe 2 ohms at most. Sometimes, there's a little bit of stray resistance in all of your wires and in all of your test probes, and you're probing with a small point. And so sometimes you'll get a little bit of resistance. Like I say, shouldn't be more than 1 or 2 ohms, but you could get a little something. But if you got more than that, that would be a problem. And what you'd like to do is measure resistance from your source, and then go to so like here, it's going from the ECM to the stud on the back of the cylinder head. See what you read there. Then go to the engine block, and then go to the dash structure. Because what you may find is you could have a perfect ground to the stud, 0 ohms, and you got a 20 ohm jump between the stud and the engine block or cylinder head, because there's corrosion in there, or the bolt is loose, right? Same thing's true on the other side. The braid goes from the engine back to the body, and if you're looking for one that goes all the way back, check the resistance between each one of those jumper points. And you can do it by putting your probes on and just going one at a time. Or you can start, I'll say put your positive probe here and keep moving your negative probe downstream and see if you have resistance. Then the second side would be, with your system powered up in voltmeter mode, do you see voltage on that terminal? And if you do, how much is it? And then as you go downstream, can you tell where the voltage drop is? Because current is flowing through the circuit, and you'll get a voltage drop through any resistance that you see, and you're looking for where the bad spot is, right? And even when I've been given some advice, I've said, hey, go all the way back to the battery. But in this particular case, say with an oxygen sensor or with a temperature sensor circuit or a map sensor circuit, where the ECM is sending out a signal to something screwed into the engine block, you probably don't really need to go all the way back to the battery. But you at least need to get, I've got a ground to the engine block, and I have a signal that's connected to the ECM, and so it's got a circuit is kind of a loop like that. Okay? The places where you can get really messed up with grounds are that if you have a bad ground, and you have multiple wires coming to the same ground point, the same stud on the back of the cylinder head, for example, if there's one level which is the wire coming from the ECM to the ground has a fault in it, or it has a ring terminals crimped on the end and that ring terminal's gotten corroded inside and it has a bad connection. Well, okay, so I got a bad ground in that wire. But now let's say that I have 3 of those ECM sensor wires all go into the same ground stud, and if you break that ground, if it's not a good ground going into the cylinder head, then you have three different circuits here. Like this one, this is just made up, but let's assume I've got a 0.3 of a volt with a bad ground, and one's got a 4.5 volts with a bad ground, and one's got 11.5 volts with a bad ground. They're all hooked together at the same stud. So this higher 11.5 volts is going to try to bleed through and upset that circuit. And it's very hard to predict what's going to happen, but you get what I'm going to call a floating ground. It's bad for you, and you'll get power bleeding into other circuits. And I say, the answers are unpredictable, what you're going to get. Which is why you really want to make sure things are 0, 0, 0. Going back to the engine again, what could go wrong? Here's my V8 or V6 with, there's a stud on the right-hand head and there's a stud on the left-hand head. And you can see these wires come out of the wiring harness with ring terminals. So you can have a bad crimp in that ring terminal where the wire is actually loose, or you can have one that's corroded in that terminal and not making good connections. The ring terminal itself could be corroded. This nut right here could be loose and not tightened down completely so that the ring terminals are moving around. And that stud going into the block or into the head may be loose itself, or again, threads could be corroded from weather, from salt, and so forth. So you really want to watch and kind of work your way through those connections to see where you might have a bad spot. And again, pulling out the ohm meter and or voltmeter is the best way to work your way through that. As I said, sometimes looking at voltage drops is a good way of finding problems. If the circuit's not powered, again, going through with an ohm meter is a pretty effective way. To talk about floating grounds, here's one that I've actually hit several times in my life. Oftentimes around trailers, because trailers, you're sending power out to the taillights on a trailer, and the ground has to come back to the car, and you got four-way connectors. Or there was a day where they didn't always run the ground. Sometimes they grounded them through the trailer hitch, through the ball, which was not a good way to do it. And the standards over time have evolved to, you go to your four-way flats or five-way flat connectors that have a dedicated ground wire. But if your ground wire is not good, or if it gets corroded, brake light bulbs on trailers, you have two filaments, right? And they share a ground. And if that ground goes away, you get some really weird things, right? The car will flash turn signal on, and the tail light will go out or dim. And what you will find is that if it's nighttime, your taillight circuit's powered up with 12 volts and it can't get to ground, so it tries to find a ground path by going back to the turn signal switch in the steering column, and oftentimes it'll find a ground and you'll get some light. And then when the turn signal tries to turn on, then the voltage across the filaments goes to 0 and the whole light goes out. And like I say, sometimes you'll really scratch your head and say, well, why did that happen? Well, we've messed with these where you fiddle around looking at your wiring and thinking that your trailer harness is bad, only to find out that you have a bad ground either at the light, the tail light unit itself, or part of the ground circuit back up to the car, or wherever it happens to be. But when you get a floating ground or a bad ground, it'll drive you to distraction. I'll just put it that way. So, kind of hope that helps. Think about going back to the service manual and looking at your ground distributions and how the ground wires come together, splice, terminate, and then using a good digital meter, measure your resistance back. You can do measure resistance all the way back to the battery, and if it's good, you're done, right? But if it isn't good, then you got to go break it down and see where is your ground path being interrupted or degraded, because it may not be zero, but a high resistance at one of these connections can give you, a lot of issues. So hope that helps. That's all for now.